Chapter 1. Venus. Halfway between Los Angeles and Las Vegas, the California country climbs southward out of the sunken basin of Death Valley into 3,500-foot-high floor of the Mojave Desert. On this immense plateau, in an area near Goldstone Dry Lake, about 45 miles north from the town of Barstow, a group of 85-foot antennas forms the nucleus of the United States worldwide Deep Space Tracking Network. Here, on the morning of December 14th, 1962, several men were gathered in the control building beneath one of the antennas, listening intently to the static coming from a loudspeaker. They were surrounded by the exotic equipment of the space age. Through the window loomed the gleaming metal framework of an antenna. Suddenly a voice boomed from the loudspeaker. "The numbers are changing. We're getting data." The men broke into a cheer, followed by an expectant silence. Again the voice came from the speaker. "The spacecraft's crossing the terminator. It's still scanning." At that moment, some 36 million miles from Earth, the National Aeronautics and Space Administration's Mariner spacecraft was passing within 21,600 miles of the planet Venus, and was radioing back information to the Goldstone Station, the first scientific data ever received by man from the near vicinity of another planet. At the same time, in Washington, D.C., a press conference was in progress. Mr. James E. Webb, Administrator of the National Aeronautics and Space Administration, and Dr. William H. Pickering, Director of the Jet Propulsion Laboratory, stood before a bank of microphones. In a few moments, Dr. Pickering said, the audience would hear the sound of Mariner 2 as it transmitted its findings back to Earth. Then a musical warble, the voice of Mariner 2, resounded in the hall and in millions of radios and television sets around the nation. Alluding to the Greek belief that harmonious sounds accompanied the movement of the planets, Dr. Pickering remarked that this, in truth, was the music of the spheres. Mariner 2 had been launched from Cape Canaveral, Florida, on August 27, 1962. Its arrival at Venus was the culmination of a 109-day journey through the strange environment of interplanetary space. The project had gone from the drawing board to the launching pad in less than 11 months. Mariner had taxed the resources and the manpower of the Jet Propulsion Laboratory, California Institute of Technology, the Atlantic Missile Range centering at Cape Canaveral, theoretical and experimental laboratories at several universities and NASA centers, numerous elements of the aerospace industry, and, of course, NASA management itself. To the considerable body of engineers scattered around the world from Pasadena to Goldstone to South Africa and Australia, the warble of Mariner was something more than the music of the spheres. Intercept with Venus was the climax of 109 days of hope and anxiety. To the world at large, this warbling tone was a signal that the United States had moved ahead, reached out to the planets. Mariner was exploring the future, seeking answers to some of the unsolved questions about the solar system. The double star of the ancient world. Venus, the glittering beacon of our solar system, has intrigued man for at least 4,000 years. The Babylonians first mentioned the brilliant planet on clay tablets as early as 2,000 years before Christ. The Egyptians, the Greeks, and the Chinese had thought of Venus as two stars, because it was visible first in the morning and then in the evening sky. The Greeks had called the morning star Phosphorus and the evening star Hesperus. By 500 BC, Pythagoras, the Greek philosopher, had realized that the two were identical. Galileo discovered the phases of Venus in 1610. Because of the planet's high reflectivity, Copernicus falsely concluded that Venus was either self-luminous or else transparent to the rays of the sun. Venus was tracked across the face of the sun in 1761, from which event the presence of an atmosphere about the planet was deduced because of the fuzzy edges of the image visible in the telescope. Throughout the 18th and 19th centuries, Venus continued to excite growing scientific curiosity in Europe and America. Even the development of giant telescopes and the refinement of spectroscopic and radar astronomy techniques in recent times had yielded few indisputable facts about Venus. Until radar studies made from Goldstone, California in 1962, neither the rate nor the angle of axial spin could be determined with any degree of accuracy. The ever-shifting atmosphere continued to shield the Venusian surface from visual observation on Earth, and the nature of its atmosphere became an especially controversial mystery. The consensus prior to Mariner 2. Venus is a virtual twin of the Earth. It approaches our planet closer than any other celestial body except the Moon, a few vagrant comets, and other such galactic wanderers. Long fabled in song and legend as the most beautiful object in the sky, Venus has an albedo or reflectivity factor of 59%. The Moon has one of 7%. In its brightest or crescent phase, Venus glows like a torch, even casting a distinct shadow, the only other body other than the Sun and the Moon yielding such light. Venus's diameter is approximately 7,700 miles, compared with Earth's 7,900. Also, as compared with 1.0 for the Earth, Venus's mean density is 0.91, their mass of 0.81 and the volume of 0.92. The Sitharian orbit, the adjective comes from Cytherea, one of the ancient Greek names for Aphrodite, or in Roman times Venus, the goddess of love, is almost a perfect circle, with an eccentricity, or out of roundness, of only 0.0068, lowest of all such planets. Venus rides this orbital path at a mean distance from the Sun of 67.2 million miles. Earth is 93 million miles. And at a mean orbital speed of 78,300 miles per hour, as compared with Earth's 66,600 miles per hour. It also has a shorter sidereal period, revolution around the Sun or year, 224 Earth days, 16 hours and 48 minutes. Estimates of the Venus rotational period, or the length of the Venus day, have ranged from approximately 23 Earth hours to just over 224 Earth days. The latter rotation rate would be almost equivalent to the Venusian year, and, in such case, the planet would always have the same face to the Sun. Venus approaches to within 26 million miles of Earth at inferior conjunction, and is as far away as 160 million miles at superior conjunction, when it is on the opposite side of the Sun. The escape velocity, the velocity required to free an object from the gravitational pull of a planet, on Venus is 6.3 miles per second, compared with Earth's escape velocity of 7 miles per second. The gravity of the Earth is sufficient to trap an oxygen-bearing atmosphere near the terrestrial surface. Because the escape velocity of Venus is about the same as that of Earth, men have long believed, or hoped, that the Sitharian world might hold a similar atmosphere, and thus be favourable to the existence of living organisms as we know them on Earth. From this speculation, numerous theories have evolved. The Sitharian Riddle: living world or incinerated planet? Before Mariner 2, Venus probably caused more controversy than any other planet in our solar system except Mars. Observers have visualized Venus as anything from a steaming abode of Mesozoic-like creatures, such as were found on Earth millions of years ago, to a dead, noxious and sunless world constantly ravaged by winds of incredible force. Conjectures about the Venusian atmosphere have been inescapably tied to theories about the Venusian topography. Because the clouds forming the Venusian atmosphere as viewed from Earth through the strongest of telescopes are almost featureless, this relationship between atmosphere and topography has posed many problems. Impermanent light spots and certain dusky areas were believed by some observers to be associated with Venusian oceans. One scientist believed he identified a mountain peak, which he calculated as rising more than 27 miles above the general level of the planet. Another feature of the Venusian topography is the lack of detectable polar flattening. The Earth does have such a flattening at the poles, and it was reasoned that because Venus did not, its rate of rotation must be slower than that of the Earth, perhaps as little as only once during a Venusian year, thus keeping one face perpetually towards the sun. Another school of thought speculated that Venus was covered entirely by vast oceans. Other observers concluded that these great bodies of water have long since evaporated, and that the winds, through the Scythian ages, have scooped up the remaining chloride salts and blasted them into the Venusian skies, thus forming the clouds. Related to the topographic speculations were equally tenuous theories about its atmosphere. It was reasoned that if the oceans of Venus still exist, then the Venusian clouds may be composed of water droplets. If Venus was covered by water, it was suggested that it might be inhabited by Venusian equivalents of Earth's Cambrian period of 500 million years ago, and the same steamy atmosphere could be a possibility. Other theories respecting the nature of the Venusian atmosphere, depending on how their authors viewed the Venusian terrain, included clouds of hydrocarbons, perhaps droplets of oil, or vapours of formaldehyde and water. Finally, the seemingly high temperature of the planet's surface, as measured by earthbound instruments, was credited by some to false indications that could be given by a Sitharian ionosphere heavily charged with free electrons. However, the consensus of pre-Mariner scientific thinking seemed generally to indicate no detectable free oxygen in the atmosphere. This fact inveighed against the probability of surface vegetation, because earthbound vegetation at least uses carbon dioxide and gives off oxygen into the atmosphere. On the other hand, a preponderance of carbon dioxide in the Venusian atmosphere was measured, which would create a greenhouse effect. The heat of the sun would be trapped near the surface of the planet, raising the temperature to as high as 615 degrees Fahrenheit. If the topography were in truth relatively flat and the rate of rotation slow, the heating effect might produce winds of 400 miles per hour or more, and sand and dust storms beyond earthly experience, and so the controversy continued. But at 1:53 and 13 seconds AM EST on August the 27th, 1962, the theories of the past few centuries were being challenged. At that moment, the night along the East Florida coast was shattered by the roar of rocket engines and the flash of incandescent exhaust streams. The United States was launching Mariner 2, the first spacecraft that would successfully penetrate interplanetary space and probe some of the age-old mysteries of our neighbouring planet.